also record this as well for those who missed the event. Cool. I'm pretty sure all of you can see my screen right now. As I mentioned, I am Sasha from Wagon, Tokyo. And for those of you who are with us the first time, Wagon is a global coding bootcamp. In other words, it's a very intensive program in school for adults. What we do here, we teach people how to code, how to build web applications from scratch during our web development bootcamps, and also how to manipulate and analyze data during our data science bootcamps. So we do it basically in two formats, full-time and part-time for those who have some family or work commitments. A bit stats, Wagon Global, we started originally in France 6 years ago. And since that time, we really expanded very fast. Right now we have campuses in 40 cities around the world. And we recently hit a very important milestone. Over 10,000 people graduated from Wagon coding bootcamps around the world. Cool. We have a lot of startups built by Wagon graduates during and after the bootcamp. This is something that we're proud, and this is something that we also want to build in Japan. A bit about Wagon Tokyo campus. That's where I'm working. We are based 5 minutes walk from Meguro Station. For those of you who have ever been to Tokyo, it's in Tokyo, in a place called Impact Hub Tokyo. If you ever want to pay a visit to know about our ecosystem or about our bootcamps, send me a message. That's about the career paths that usually our bootcamp graduates take after the graduation. A lot of them become developers. Some of them who want to juggle both business and programming side become product managers. Some of them launch their own startups or go freelancing. That was for web development bootcamp. For data science bootcamp, I would say that a lot of our alumni become data scientists, but also the data analyst and data strategist and data engineer paths also possible. Cool, and this is a cool perk that I would like to recommend for those of you who want to learn programming from scratch. We are running a free online course from May 11th. That's really cool course. We're running for the 5th time already. Over 300 people benefited it, completely free. Really free. If you're interested, I will send the link after that for registration. The application closes on May 7th, so if you're interested. Cool, that's enough from me. Right now, I am giving a microphone to Jeff. Jeff, please go ahead, the stage is yours.
Thank you, Sasha. If hopefully you can hear me fine. If my audio cuts out or something, please give me a shout in the chat. Really appreciate the opportunity to present to you all today and take you through something that is of great interest to me, and looking forward to sharing it with all of you. So a few housekeeping pieces. Well, first of all, let me thank Wagon and Sasha again for this opportunity. The coding bootcamps are a great institution. Some of our engineers have been graduates of coding bootcamps, and really wonderful. So please keep up the good work. This is going to go for, I think we're scheduled for an hour and a half today, and I will try to keep to that time just to be respectful of everybody's agenda and schedule. But I do have time afterwards. So as we go through the agenda, I'm going to pause sort of between the sections. I think there's 5 different sections. And if you have any questions, please put them in the chat. Just given the number of people there are today, I think that's probably going to be the most efficient way. Put your questions in the chat. I'll take a pause, take a look at the chat, and try to pick up any relevant questions from the section before. And maybe at the end, we may have a chance for a little bit more interactivity. So without further ado, this is blockchain app development for beginners through non-fungible tokens. Introduction to blockchain app development. We're going to go through these sections: intro to blockchain, NFTs or non-fungible tokens and why they matter, smart contracts, otherwise known as computer programs on the blockchain. And then we're going to really dive into some code. So NFT smart contract build along with the web-based Remix IDE. And then we're going to talk a little bit about the future. And there's many different topics. We could have done an intro to blockchain workshop on. NFTs, non-fungible tokens, are very topical at the moment. and very new. They're not new, but they are actually quite new in the broader sense of them. And so it's important also to think about some of the concerns that have been raised around climate impact, usability, and long-term prospects. So prerequisites, I'm just pulling this, of course, from what we put into the course description. Basic programming knowledge, keen interest to learn. What we want to do in this course is we're going to spend actually quite a bit of time on what doesn't look like programming to start, but is very important to understand the blockchain programming. If we dove right into the code, I think a lot of the subtleties could be missing. And this is also, aimed at an introductory audience that doesn't have a lot of necessarily blockchain or programming experience. So we want to certainly, make sure that we're kind of being as inclusive as possible. Desktop web browser, if you want to do the smart contract build along, there are no other prerequisites required, nothing to download. I will share links as we come to them. And no prior knowledge of blockchain. So I'm going to start right from zero, although I'm sure most of you have heard of blockchain before. So here we go. So introduction to blockchain, first section. Let me just check the chat to see if there's any questions before we get started. Where are we here? Free programming course. Okay, great. No questions. All right, perfect. Introduction to blockchain. So first, 2-page overview of blockchain. What is it? Blockchain is basically a database that is distributed amongst all of its participants globally. And typically this would be thousands or tens of thousands of different participants. So these participants can transact securely over the internet in a peer-to-peer sense without having to trust one another. You think, how is that even possible? How can they interact or transact without having to trust one another? But you think about it, we do transactions every day in our daily lives where we don't necessarily trust or even know the person on the other end of the transaction. If we're making a purchase off of Amazon, or even could be from a store that we don't necessarily know, and we're relying on middlemen, people in the middle, organization in the middle, to be that trusted platform. So Amazon is the trusted platform. If it's a bank wire transfer you're sending, your bank is the trusted platform, or your credit card company is the trusted platform if you're transacting in a store that maybe you don't know. That's what we mean by traditional transactions. On blockchain, the trust is in the system. And it really started with Bitcoin in 2009, and it's confusing because Bitcoin refers to both the cryptocurrency Bitcoin as well as the underlying blockchain platform, Bitcoin. So you have the Bitcoin blockchain, and an application that runs on top of it is the Bitcoin cryptocurrency. So, in terms of how big Bitcoin is today, I probably don't really need to speak to that. What I will talk to here, though, is how this transaction actually works. So in this case, we have kind of the classic computer science 101, Alice and Bob, 2 participants in the system. Alice wants to send Bob 1 Bitcoin, which she does. And she does that by signing a transaction with her private key and broadcasting it to the network. And all of the other participants verify that transaction and then update their ledgers. And by ledger, I mean their transaction history, kind of like a spreadsheet. And we'll take a look at that in a little bit. So that's Bitcoin. That's a very simple blockchain example. Second page of the 2-page overview. So essentially what happened a few years after Bitcoin is people got the idea that, wait, rather than just using this for data, what if we can use this for computation as well? And or let's say a simple transaction, rather than just a simple transaction, what if it was a complex transaction? And another way to think about an arbitrarily complex transaction is as a computer program. And so rather than just having this distributed set of verifiers essentially update transaction ledgers, update their ledgers, or update their spreadsheets almost, if you will, with simple balances, why not have them run computer programs? And so that's what a smart contract is. A smart contract is a computer program that runs on the blockchain, that can do computation, that can store data and retrieve data. And that really started with the Ethereum blockchain, which got going in 2015. So that's the real difference between the two. Bitcoin is very simple. Bitcoin blockchain is very simple transactions, and any blockchain that's similar to Bitcoin. Ethereum is much more complex transactions. In fact, computer programs that run on the blockchain. I'm going to start to go a little bit faster after this, but I wanted to just kind of lay the groundwork with those two kind of concepts. So why is blockchain important? Like, what can it be used for? I'll call out three ideas here, right? So the first is flat transactions and low fees. So you could pay as little as a few cents or a few yen to send any amount of money globally in seconds. And we talk about the disruption that's possible in terms of existing business models and companies. You could look at MasterCard as a credit card company, Swift as an international payment network, or Christie's as an auction house, for example. When we talk about complex transactions, you're not limited to simply a financial, a simple, plus one, minus one plus one. We can model stocks or bonds, or we can model real estate contracts, or we can model art contracts. We can model any kind of contract with no middlemen, low fees, and fast confirmation and clearing. And it can also act as an escrow service. Not just financial escrow service, any kind of escrow service. And so when you look at the kinds of companies that can be disrupted by this, or the business models, the business models that will need to adapt to this, it's not just financial companies, it's not just stock exchanges or insurance companies, it's the sharing economy, Uber or Airbnb. So that's why blockchain is important. I mean, it is a very obviously, I'm the co-founder of a blockchain company based here in Tokyo. The glass is half full for us, but we really, I really do believe it's going to change the world. So NFTs and why they matter. Now, I'm going to pause here for a second. Any questions in the chat? Nope. We'll keep going. So art and blockchain. First, what is art? It's a very existential question. Here we have, I see a question coming just past the, what is the blockchain tech we're working on? We're working on a kind of middleware layer that makes it fast and easy to build on top of the blockchain. And I will show you that towards the end. Thank you, LD, for your question. So moving on, next section, NFTs and why they matter. An NFT or non-fungible token can represent many different things. And we're going to talk about it in the context primarily of art, because it's very topical right now, and it's we have to pick one example. So we're going to pick art. So first of all, this very existential question, as I was saying, like, what is art? We've got the Mona Lisa there. We have some First Nations art. We've got sculpture and a digital art, and another very famous painting. Art can take, of course, many different forms. It's a very personal thing. But there's a few characteristics that we can kind of think about. But before that, actually, one key thing to consider here when we're thinking about art is thinking about the art itself, the original art itself, in this case, the Mona Lisa on the left. And on the right is a reproduction of the Mona Lisa. Like, what does it mean to have the original Mona Lisa hanging in your apartment versus a very good picture of the Mona Lisa? Like, why is one worth, well, priceless, really? I mean, hundreds of millions of dollars, if not $1 billion, maybe, versus a very, very high fidelity reproduction. Could almost be a perfect reproduction. In fact, maybe it's not a photograph of a painting. Maybe it is a very good artist who has copied every single brushstroke on canvas in a frame that looks the same, and it's hanging in your apartment. Why is one worth so much and the other one is simply considered a copy and maybe not worth as much? So when we start to think about art and the blockchain, and I will talk about how and what a non-fungible token is and how that represents art in a minute. We start to think about art and the blockchain. Some of the things that we can think about when we have this globally distributed ledger and this database is that we can start to track things on it. We can start to track the provenance of an item, of a piece of art, who created it, who has owned it, how was it stored and displayed. And we can do that in a way that is completely transparent, because remember, again, a public blockchain is shared with anybody who wants across the internet. We can start to look at the value of an item, right? And coming back to, for example, the idea of the Mona Lisa itself versus a picture of the Mona Lisa. I mean, when the Mona Lisa was painted, I'm sure the cost of the materials was probably a few $100s in cost of those materials. Or think about something that doesn't take into account who created it, but let's say a baseball card, a trading card. The Mickey Mantle was a famous American baseball player. A card from his first year, his rookie year, will sell for $2 million. It's pennies of paper and ink. So already, we have this concept, even without bringing the blockchain into it, of separating the value of a piece of art or an item from the cost of its materials. Ownership. Who has a possession? Are there copies? Are they high fidelity copies or even exact copies? And well before we start to think about blockchain and recording some of these items on the blockchain, digital art, video and images and sound and music has been around for a long time. And if you have the original digital master recordings of your favorite musician, and it's an exact copy, you can listen to it, but it has a very different value from actually having that master tape and owning the rights to it, which is the next thing to consider, right? The right to transfer or sell or lend or derive or commercialize that item as well. So these are some of the key considerations, and we're building into how this fits into NFTs. So we're going to go into a case study. Many of you have probably heard of Mike Winkelmann, aka Beeple. He is a digital artist that for the past 13 years has been producing a new piece of art every single day. Even on his wedding day, on the day when his child was born, he produced a piece of art and published it on the internet, I think primarily on Twitter and Instagram. And January of this year, he got to 5,000 days, and he took these first 5,000 images and put them into a giant collage and decided to sell them. He didn't just sell them as a print, as a physical print. He actually sold the image file, the JPEG file, all 320 megabytes of it, this massive JPEG file, and he did it as an NFT. So now we're going to talk about what this means. And I'm going to refer to, because the auction is now over, so I'm going to refer to some slides to show you what this looks like. Now, he auctioned it on Christie's, which is a world famous auction house. I think it's headquartered in London. You would auction your Leonardo da Vinci notebook or painting, or your one of a kind Ming Dynasty vase, for example. This was their first NFT or digital item. This was a screenshot of the collage. There you can see it on the left. 3 days before the auction closed, when the bid was still at $3.7 million US. And of course, if any of those have been following along, it sold for $69 million US. 60 million went to Mike, went to Beeple. $9 million was the buyer's premium that went to Christie's auction house. So for auctioning a JPEG on the blockchain, they took a $9 million fee. That's pretty good. Now I'm going to flip over to a little bit more interactive. Before I do that, I see a few questions popping up. I'm going to pause here. Here we go. How does fund transfer in seconds relate to unpredictable? Okay, I'm going to come back to that question. That is a very good question in terms of time to actually mint something. So we're going to open up the web page here. Here we have the Christie's website. I can close this. This was the opus, the article they wrote about it. We'll click into this, and this is the actual page itself. If any of you've looked at this, you can of course Google this. You can always share a link afterwards as well. $69 million and change. And what they put down here is a token ID, a wallet address, which is Beeple's wallet address, the smart contract address, which is the address of the computer program on the blockchain, and some more details about it. It's a giant JPEG file, and this is unique. It was the only one that was per se minted. So basically what we're doing is we're representing this image and its characteristics we're representing it within within a smart contract or within a computer program on the public Ethereum blockchain. And so I have this here actually open. So there's the smart contract address. This is actually Beeple's wallet address. You can see this here. He does not have $69 million in here because he took the funds in fiat currency instead. This is the transaction. And what you will see here is maker's token V2. It's another smart contract. So this is, I should take a step back. This is a website called Etherscan, which is what's called a block explorer. And what this shows us is all of the blocks that are mined or created on the Ethereum blockchain. And a block is just a way of wrapping transactions together, of grouping transactions together, and essentially adding them or appending them into that ledger. And I'll talk a little bit more about this going forward, but you can see in each block, there's some number of hundreds of transactions between different wallet addresses. I will come back to this, but this is the maker's place token or smart contract. Those terms are not quite equivalent, but they're interchangeable. This is the source code for this digital media core smart contract, this program on the blockchain. It's open source. Anybody can validate and verify the source code if you wanted to. It's about 2,000 lines long. And you can also on Etherscan use these functions to actually both read from and write to the smart contract, right? So for example, we can see that there are the total supply, there are 54,474 tokens. We can see that is there a name? There probably isn't. We can see 54,474 tokens. If we come back to the Beeple, if we take this token ID 40913 and we come back to Etherscan, where are we here? And we look at the owner of token ID 40913. This is who currently owns Beeple, this address. We'll click into this address and we can see that this address is called the B20 contract deployer address. It has $19 million of tokens on it. It doesn't count the Beeple token, this website, because it doesn't know what that's all about. But this is a group by the name of Metapurse, led by an individual called Medicovan out of Singapore that actually bought the Beeple. What else can we see from this? So this token ID 40913, we can see the token URI or URL, Uniform Resource Indicator, I think. Now, this is what's called an IPFS or Interplanetary File System link. And this will either give us the image itself or the metadata about the image. So I'm going to paste this in. I happen to have it cached. And here is the metadata, right? So this is Beeple's first 5,000 days. We can see information about it. If we look at the preview media file, we're actually going to pull up that collage. And if I were to go down to the media file itself, the raw media file, and click on this link, I would actually download the 320 megabyte digital file. And so, again, you think, why would somebody give away their art like this? I mean, give it away or put it out there. Well, it's a digital file, right? And it's a choice of the artist. Do they make the full high fidelity file available, or do they keep that secret and simply put the signature in the metadata of the NFT? And Beeple has decided to make that available for anyone. So, what would be the equivalent of this in a traditional art world? Well, the equivalent would be a paper certificate, or more likely a book of paper certificates and proof by experts that this painting or this photograph is the original. Here's the photographs of all the places it has been in its throughout its life, throughout the 50 or 100 or 500 years that it was in existence. Here's the X-ray analysis that we did of this particular artwork, and to prove that it was in fact created by Leonardo da Vinci. And you know, there's a cost to producing that kind of certification and to maintaining it. And that's basically what an NFT is replacing. A non-fungible token. Non-fungible refers to the fact that it refers to something unique, something with a serial number, right? It's not you know, coins in a drawer, or it's not bolts in a box. It's a car or a piece of real estate or a piece of art. It's a unique, individually identifiable thing. And by following this standard, one of these NFT standards, we are now able to essentially not only represent an item like this, but transact as well. And that's what I mean when we come back to this transaction hash. So this was from Beeple to this address, which it's not the medical van one, it's an intermediate one. This is probably the Christie's address. But essentially, they called the safe transfer function, right? It's a function within that smart contract, within that computer program on the blockchain, to move the Beeple, to say this Beeple, the ownership of this art is moving from this address to this address. And there's the token ID. It's all encoded, of course, with hexadecimal. The first two are addresses. And the third one, if we decode that, if we turn that into decimal, is the token ID. And moving this piece of art cost about, this is the current value, cost at the time about $20, about 2,000 yen to move this art. Now think about how much it costs to ship a physical piece of art, or even a digital piece of art, with all the certifications and like, yes, this is the original one, and absolutely we have it. And this entire transaction took place on the blockchain for about $20 in transaction fees. So I have gone for quite some time there. I am going to pause and see if there's any questions. I'm going to come back to that one. There are any similarities between NFT and DRM? DRM is digital rights management. Absolutely. You can replace a lot of digital rights management with NFTs. Who owns something, right? And when you combine it with the concept of being able to put payments onto a blockchain as well, you can imagine that a lot of the complexity around, you know, coming back to music, for example, the very complex music or film or TV royalty payments, where a single song, you know, may have parts of it, different parts of the copyright and different aspects of the licensing owned by dozens, if not hundreds of different individuals and organizations that all need to get paid under certain circumstances. You could absolutely build that entire scheme into the blockchain, because you can run computer programs on the blockchain, you can handle payments on the blockchain. So all of that can happen start to finish. There's also an aspect of DRM, digital rights management, around encryption and who has the right to view something. The public blockchain is right now very, very good at tracking ownership. But because it's public, you know, you can't put private things on here in an open kind of way. You would need to encrypt them somehow. And so that's definitely possible, but I think it's probably a longer story or a longer journey. Chat. Okay. The first record ownership, what prevents the act from publishing exact replicas of this art in another smart contract, Ethereum and otherwise? That's a great question. I would come back to the question of, if I have a digital copy of, I was going to say the Beatles, but you know, their master tapes, of course, were recorded on analog tape. But if I have an exact digital copy of, I don't know, pick a more recent artist that might have only recorded on digital, like I don't know, Bjork, for example, right? A really forward-thinking artist, a musical artist like that. You know, her master tapes may only exist in digital form, and I have a copy of the digital masters. My friend over here has the copy of the digital masters. Which one is the original, right? So there would be nothing preventing both of us claiming that I have the original one or they have the original one. And it's the same thing with an NFT. There's nothing ultimately preventing anybody from minting the exact same thing, except the fact that, for example, in the case of Bjork, or let's use the example in front of us here, Beeple is a real person. And he goes to Christie's, which is a trusted source that publishes his wallet address. And this item is his work and has done some amount of, you know, confirmation. And that is one way that we can build kind of this web of trust around this NFT. Now, if he was to go mint another one, right, of the exact same item and say, no, this is the real one, of course, you know, the art world could be thrown into disarray and you're just trying to make money again. And this one was 69 million. What are you doing? You know, but it's no longer a blockchain problem at that point. It's a people problem. And I think the key thing about blockchain technology is that it's not a replacement for any of the existing societal structures or organizations that we have. It just can make things easier and faster and more clear. Can I elaborate on yeah, an NFT transaction so regular art transaction. Can I elaborate on the difference between a regular art transaction and between two individuals in the real world and an NFT transaction? Please list details. So, you know, if you were to go buy a digital item, let's say, right? I mean, a real world transaction between two people, but a digital item, let's say, you know, you might go to the artist's website and they might say, I'm selling 100 copies of this print. I'm only going to sell 100 of these JPEGs, or a physical print. I'm only going to sell 100 of these physical prints. I promise not to print anymore. You put your credit card down or your credit card in, and they either send you the file or maybe they mail you the real print, and you have that. And you know, you now own it, and it's a transaction like that. And the fact that whether it's authentic or not would come with, there would be some sort of certificate from the artist or some way to go back and check with the artist to basically validate that was real. But in order to do that, you can't just come to a website like Etherscan and type in the token number and, you know, look at, everybody knows Beeple's wallet address. Somebody would have to write to the artist and they have to say, yes, I sold it to this person years ago, or you know, this numbered print I sold to this other person, and I guess they've sold it on subsequently. You know, there's another whole aspect of how do you know the artist is not cheating and printing, you know, not just 100 copies but 200 copies to make more money. So that's kind of where some of the crossover is. Who's the transaction fee paid to? Great question, Luke. The transaction fee is paid to the network. So just like you have Amazon Web Services or Google Compute Platform or Microsoft Azure as a centralized cloud computing platform, you can think of the blockchain as a decentralized computing platform. But it's cash on the table. You don't get a bill at the end of the month. You get a bill for every single transaction you make. And that $20 is going to two things. First of all, it's going to, it's actually going to the organization that does what's called mining the block. And we can talk about that a little bit later in the presentation. I have a couple slides on that. But ultimately, like at a theoretical level, it's going to pay for the security of the network. Part of that cost is a computational cost around securing the network. And part of it is the fact that these bytes, which it actually doesn't say how big this transaction is, but let's take, for example, a block. Which block was this in? We say here, do we have a block number? Doesn't matter. We'll go back up to the top of Etherscan, and we'll take a look at a block. This block here, all the transactions in this block were about 41,000 bytes, 41 kilobytes. Everybody that's interacting, everybody that is working with the blockchain needs to store this 41 kilobytes forever. So that's the other thing that it goes to pay. Yeah, Kane, great comment. The Wu-Tang album is a great analogy for this as well. Okay, so let's move on. So that's Beeple. I don't want to spend too much more time on this. It's fascinating to go down the Etherscan rabbit hole and just sort of see what else is there. We've kind of looked at all of that. I wanted to call out one other kind of case study, which is a digital artist called Pack. And Beeple, more traditional digital artist, making these drawings and then turned it into a single NFT and sold it, and kind of, you know, had his windfall. Pack, on the other hand, has been experimenting with NFTs for quite some time and has been a digital artist for quite some time. And Sotheby's, another big auction house, not to be outdone by Christie's, their rival, has partnered up with Pack to release a series of NFTs. The auction is actually ongoing right now. It finishes today. Today's the last day. this is, I would recommend checking this out because it's a completely different take on how to approach about what an NFT could be or is, and how art becomes marketing, and marketing becomes art, and it's kind of a mind game. It's a little bit of a mind game. So I will leave it at that. You can Google Sotheby's PAK, P-A-K, and I do also recommend taking a look at his Twitter, Murat PAK here. Yeah, it's very, very fascinating to sort of show like what no longer looks kind of very like a kind of a standard art sale transposed to the blockchain, but really a kind of unique way of doing things. All right, so that is that. Now we're going to talk about smart contracts. I am not going to, let me take a look. There's no questions at this time. I'm just going to push through since it took a bunch of questions. So smart contracts or computer programs on the blockchain. We're going to take a step back again and think about what the blockchain is. So the blockchain at its essence is a decentralized ledger. In this case, we're taking as an example the Ethereum blockchain because it uses smart contracts. But there's of course many other blockchains out there with you know, similar or different characteristics. But this is the Ethereum blockchain. ETH, or these sort of 3 lines, is the currency symbol for Ether. You can kind of think of this like a double entry bookkeeping ledger. If any of you have ever taken, you know, Introduction to Accounting, right? We have a debit from one account and a credit into another account. So Alice is sending Bob 2,000 Ether. Transactions on the Ethereum blockchain are atomic. So either the entire transaction happens or none of it happens. And we will never get into a situation where, you know, I don't know if any of you have had a problem like a bank error where either money showed up into your account that you didn't expect and you were all excited about, or money disappeared from your account that you did not expect and you were not so excited about. In either of those cases, at some point, either the bank called you or you called the bank to say, what is going on? The bank said, oh, sorry, we made a mistake in our software, in our centralized database. Let me fix that for you, sir. It's gone. And you look back at your bank, you know, you log into the bank website and the entry is just gone, right? That is the kind of mistake that can't happen on the blockchain because all transactions are atomic. Either the whole thing happens or it doesn't happen. Transactions are grouped together into blocks, and blocks are appended to the ledger, and they're immutable. So I mentioned spreadsheet a couple of times before. This is sort of what I meant. This kind of looks like a spreadsheet that's always growing downwards forever, right? One block at a time, one chunk of transactions at a time, one chunk of lines at a time. And here we have 2 transactions between Alice and Bob and Carl and Diana. We don't actually use these nice names, these account names. We use very large numbers, 2 to the power of 40. So, I mean, that's a massive number. There's roughly the same number of Ethereum account addresses as there are atoms in the planet Earth, which leads to a couple of interesting things. First of all, you can generate your own address randomly on a computer or a smartphone, and you can be quite certain that nobody else has ever generated that same address again, assuming the randomness is sufficiently good, which, you know, is part of the magic behind the scenes. So you can generate one address, you can generate 10 or 100 or 1,000 addresses. You could use a different address for your NFTs. You could use a different address for your, you know, for your cryptocurrency. You could different address to play blockchain-based games. You could, if you're a business, you can use a different address for each of your customers. And when we talk about these addresses that get generated, the concept here is not so much, again, because we're in a decentralized world, we are essentially becoming our own banks. We generate our own account, public and private key pairs, which is what this is, and are responsible for them. So in this paradigm, there's no, you know, the advantage is low transaction fees, high throughput. The disadvantage is that if you lose your private key, if you lose your essentially very long password, your money is gone. And you can read about lots of cases where people who were very early into cryptocurrency misplaced their private key, and they had 1,000 Bitcoin or something like that, they would be millionaires today. So that's very, very important, and also one of the usability challenges. So not names, accounts. Transactions, as we've seen, we saw the safe transfer from for the people transaction. Here's one we called remit. They can include computer code that will run on the blockchain, right? So that code actually acts as a transaction. Transaction can simply send Ether, but most of the transactions on Ethereum are actually running some kind of computer code. And Bob here may in fact not be a person. It could in fact, Bob in fact could be a smart contract. So smart contracts can interact with one another, and people can also interact with smart contracts. And here's an example of this, the contract code for Bob actually getting uploaded to the Ethereum blockchain in a transaction. So to recap, computer programs on the blockchain are also called smart contracts. Sometimes they get referred to as tokens, as a particular class of smart contract, non-fungible tokens, fungible tokens. They can hold and dispense value or Ether. Excuse me, they're governed by the rules of their computer code, and they are immutable. They can be inspected and invoked by anyone who has access to the blockchain. Now, this is important to think about for two reasons, right? And let's go back to the Maker's Place token here for a minute. So I trust this smart contract with my $69 million or my $10 or my $1 because I can see the code here, and I know this is the code that's running on the blockchain. And I'm not going and looking at every single piece of computer code, but if it matters, maybe I would, or maybe I would pay somebody else to, or go and read in forums or look at audits of people that have audited this code. It's like radical transparency, right? I mean, when's the last time your bank let you look at their computer code that they were running? I mean, never, right? They never would. It's their private intellectual property. But this is kind of radical transparency in that sense. So the code is all out here. That's number one. Number two, anybody can call this smart contract code. So we have to protect it, right? Just because the code is public doesn't mean that we're going to allow anybody to, for example, burn a token or pause the contract, right? The only people we're going to allow to do this are people that are authorized. And so we have to build that authorization layer in there. And so there is somewhere here an owner of this smart contract, which is this address, and this address probably owned by Maker's Place. And they would be the only ones that are allowed to essentially pause or unpause this smart contract, for example. And the owner of a token would be the only one that could transfer it, or the only one that could burn it. But we have to build that authorization layer into it. And they cost gas, which is another way of saying the transaction fee to invoke, and depends on the blockchain. Actually, 5 yen is not even low enough. I mean, it can cost, if you're running your own blockchain, it costs you nothing. If it was other blockchains like an XDAI or Binance Smart Chain or Polygon, could cost you fractions of a yen. Very, very, I mean, almost nothing to run a transaction, up to 100,000 yen or more. Let's say for deploying a contract on the Ethereum blockchain, just based on current popularity and prices. And the limit on transaction fees for block essentially per block essentially prevents these kinds of runaway smart contracts. So I had some sample before I go on. Atomic means can't be split apart. Like, it's very hard to split an atom. You can't break apart a transaction. Either the whole transaction happens or none of it happens. We touched on the concept of sovereign identity or self-sovereign identity. Well, self-sovereign identity, if I have a wallet address that's on my mobile phone and backed up on my computer, and it represents me, it's almost like it's my, I won't make the analogy, I am the non-fungible token, but essentially I have this wallet address and I can prove that it's me. Then it becomes more than just a store of value. It can become my identity, right? My identity as a person, right? What if my school issued a record, a non-fungible record of my diploma onto the blockchain. You think, well, like, what's the use of that? But actually, the UNICEF and UNHCR, United Nations something refugees, basically the High Commission for Refugees, is issuing non-fungible tokens for people that are earning certificates in refugee camps because their schools don't exist anymore, or their country won't recognize them as citizens or residents, the country that they came from. And so, you know, that's the concept of self-sovereign identity, that yes, it's important to have an identity, obviously, like, again, existential question, as people. It's important, if we can, to have an identity within a political entity like a country, but there could certainly be value to having a kind of self-sovereign identity to track some of these things as well. Yes, going beyond the surface, Nassia, absolutely, without too much tech. And hopefully some of this presentation is giving a sense of that it's possible to look into this without having to be super technical. In a way, smart contract highly customizable. Yes, absolutely. You can write your own smart contract, but again, you know, you can use one that somebody else has written. But again, this comes back to the whole concept of it's just a technology or a tool, and it's only as good as, or only as powerful as, the people that are agreeing to use it. Right? This only has value because we all believe in it. But that's very true of many things, right? Like a country's currency has value because people believe in the country and trust the country to not print too much money, so that there's hyperinflation, and to you know, uphold the laws of its citizens, et cetera, or the laws of the laws, you know, its laws, and to do right by its by its people, and you know, the broader world, et cetera. Is it dangerous to have the code open to the public? I mean, the alternative is that it's closed, but then I mean, this is really the whole concept here of public blockchains, is taking things to the level of radical transparency. Now, do you have to make the blockchain public? And do you have to make the code public? No, you don't. You can, in fact, when you deploy a smart contract to the blockchain, you don't actually, where is this here? You don't actually upload the source code. What they've done is they've uploaded the source code onto Etherscan. Etherscan has compiled it, compared the compiled code to the bytecode, which is down here. This is what's actually on the blockchain, and said, yes, it's matched. Here it is. It's not a requirement to do that. So even on the public blockchain, you can certainly keep the source code private. It's just that for these kinds of applications, non-fungible tokens or art, you want to make the source code public so that people will trust it. Yes, you know the transaction cost before transacting. It's displayed to you when in like the pop-up that comes up. Okay, great. All right, we've cleared the questions for now. So I'm going to come back to this. I'm going to show you actually some sample Daps and what those look like. So first, we're gonna jump right in to a kind of an advanced application with a very simple concept called Uniswap. And Uniswap is basically like an online currency exchange, if you will, or online. It's almost like an online stock exchange, but basically an online currency exchange. And it allows you to transfer. So this is Uniswap here, right? This is their website. Now, when we talk about a DApp, right, or a which is short for decentralized application, there's two parts to that. There's the smart contract that runs on the blockchain, and then there is the there's everything else that plugs into the smart contract. The simplest or most basic way to think about that is I have a website, and it talks through some gateway to the smart contract. And connected to this website, I have somewhere that, because it's not just a website, right? I need some way to basically be able to sign transactions. And so I have a browser extension. This is one called Metamask, which generates and stores my private public key pair. So this is my public address, 0BAC1, etc., the long string I showed you. In behind that, which I will never see, generated and stored within this browser extension and hopefully backed up somewhere else, is a private key, right? So what will happen when I access this DApp and say I want to change from 1 Ether to, I don't know, let's pick a token like DAI, which is a stable coin, right? Which represents $1 US. So 1 Ether for 2,000 DAI or US dollars. In fact, to make it even clearer, because it could be confusing, we'll pick USDC, which is another stable coin. So basically the same exchange rate. Now, I don't have sufficient ETH balance, but actually, I wonder if I can just do 0.0001. Is there a minimum? There's not. So, oops. So $2, $23. I'm going to switch to a wallet on here that has a little bit of money in it. And what you will see here is now I can click swap. And if I click swap, what's going to happen is the web page is going to send a message to my MetaMask extension asking me to sign a transaction, confirm swap. So there we go. Here we have, there's a fee that the DApp, that the smart contract takes off the top of 0.00003 ETH. There's a price impact. This refers to something called slippage, basically. Actually, I think that's incorrect, but I'm not an expert. And waiting for confirmation. So now I get this MetaMask pop-up, and it's going to say, for the pleasure of swapping, what was I trying to swap? I'm trying to swap like $23. You can pay $57 in, sorry, $33 in gas fees or transaction fees. That's kind of ridiculous. And I'm going to reject that. And it's kind of ridiculous if I'm trying to swap $23 or send somebody $23. But if I'm trying to send $1,000 or $10,000 or $100,000, I will pay the exact same fee, because the transaction fee paid is just the incremental fee, the incremental cost to process that transaction and secure it and store it on the blockchain. So this kind of transaction used to cost 50 cents several months ago. And then blockchain got really, really popular. So basically, what's happening now is the blockchain only has a certain, the Ethereum blockchain only mints a certain number of blocks per second. It's actually 1 block every 12 seconds. There's only a certain number of transactions that can be included per block. You'll notice that it's variable here. It's actually based on the amount of transaction fees, which is related to the amount of computation that happens in each block. And so essentially people that are not doing a $20 transaction here, but like $1 million transaction, are bidding up these transaction fees. And let me show you what that looks like, actually. Sushi chef. So here's a transaction from several months ago. So this is from last September. And this is a transaction that for reasons, they paid about $90 in transaction fees, and they exited what is currently worth 150. They did a complex, basically a complex financial transaction involving various automated market makers and a concept called yield farming to basically extract $153 million from, basically it's like a trade that they did, like a stock trade. They did a stock trade that netted them $153 million in current value. At the time, I think it was worth about 15 or something like that, but Ethereum has gone up so much in price. So, and they still only paid $90 in transaction fees. Now you imagine if you called your stockbroker and said, I want to trade $153 million of stock. They're going to say, great, give us like a few weeks, and we'll charge you like $50,000 or probably more, maybe $100,000. In this case, they did it themselves, probably from a web browser. They paid $90 in fees, and it happened immediately. I mean, this transaction happened in OConfirm within 30 seconds, right? So $23 is expensive for a $30 transaction fee is expensive for some things. And you may not want to wait a few seconds or maybe say 30 seconds for a transaction to confirm in some cases. But for other things, it's absolutely game-changing. So that is Uniswap, decentralized finance. Now I want to talk a little bit about NFTs. So these are all what are called NFT marketplaces. OpenSea is probably the most famous and most well known. You know, here we have, for example, an NFT called Nyan Cat, you know, we come in here and I can see it's this digital artwork, this kind of like pixelated GIF, and you know, it was last sold for 2.5 Ether, about $5,000. And the reason somebody paid $5,000 for this has everything to do with the provenance of the artist and this particular piece of art, and nothing to do with the fact that it's a GIF that you know, a talented artist could make quite quickly. But here we see, we are here's the OpenSea, right? We can see the listings when, you know, what this particular piece of art was listed at. We can see that the offers that were made, and we can see its trading history, right? So it was, I don't know if we can see last time it was sold. It was sold for 2.5 ETH 7 hours ago, about $5,000. This is the web interface. This would plug into the smart contract, right? So the smart contract is behind the scenes here. And I don't know if it lists the address here. Properties, nope. Chain info, here we go. Here's the smart address. Here's the smart contract address on Etherscan. It's Nyan Cat. We can come into the contract here. It's a Rarible token, so it's another piece of code. This code happens to be, you know, probably, you know, 1,000 lines long. And what was this token ID? This token ID is 9, and we can see who is the owner. Where do I find that here? Balance of is owner at creators. Put 9. It's going to output this address 484E. If I come back to here, can I see the current owner? They may be hiding it, but whoever the current owner is, where are we here? Owner Metadiver from Ouroboros. If we look at this, we can probably see here, we start to go down a rabbit hole, right? But basically the point is that this is a blockchain application that's a website with a backend that is plugging into the blockchain, and the blockchain is what is providing the value and the security around this NFT. If I want, I can come here and I can create, it's a little more complicated here. So I'm actually going to go to a different NFT marketplace called Zora, which is one that we like a lot. Hopefully this website's going to load. In fact, I'm going to close this because oh, there we go. So I can click create here, and I can, if I wanted, I can now actually create an NFT. In fact, I could create one of the Curvegrid logo. And you could type, you know, title. Oh, here we go. Continue. The title, Curvegrid logo 2021. Description can be red logo, black text on white, digital 2021. And I'll click continue. And now I can, this smart contract has other properties. Somebody was asking about properties of smart contract that will allow me to take a percentage of all future sales. Now, hold on a second. Fascinating. Here we start to get into some of the possibilities of NFTs and smart contracts. Encoded into the rules of the smart contract is the ability for the original creator to get a certain percentage of all future sales of this NFT. Which is just not possible in the traditional art world, or certainly not leasable. You sell a painting and like, that's it, it's gone, right? If it appreciates in value, you'll never make any more money from it. And whether this is something that an artist should or should not be doing, the fact that they have this optionality, I think, is very, very important. Finalize and publish. I'm about to release this logo. I'm not actually going to do this, but it's going to upload the artwork to their server. And then it's going to prompt me in a second to sign a transaction, and you're going to see how much it's going to cost to mint this NFT on the public Ethereum blockchain. Here we go. $119 in transaction fees. I'm not going to do it. I don't think I would make my money back. But it was a fun exercise to try. So that's a few examples of Daps, decentralized applications. One of the other really famous ones is NBA Top Shot, which uses a different blockchain called Flow, and it is much more private and controlled, and to the degree where currently you do not control your private key. They manage it for you, and it's basically a walled garden at this point. Someday they will hopefully open it up, but they've done very well. They've made something like $500 million off of minting these moments and people buying these moments. All right. We're going to get to the build along in a second, but I'm going to go back to the chat and yes, just show that to you how the purchasers can receive royalties. So any transfer, any purchase would go through the smart contract. The smart contract would just shave off 10% of that and give it to the creator, and you would just have money show up in your wallet, cryptocurrency show up in your wallet. And an extension of that, of course, could be kind of the music industry example that I spoke about earlier, where it's not just the original creator, but you could have a very complex web of who gets paid for what. And why are people not doing that yet? As we're about to see, building smart contracts is actually quite difficult. Building applications on top of the blockchain is still quite difficult. We've gone an hour into this and we haven't even looked at code yet. So, that's the reason why we're not doing all of that yet. All right, so for this example, I picked one that hopefully is fairly accessible from a conceptual perspective, relatively deep in that it's another fun rabbit hole to potentially go down. And in fact, what I'm going to do now is I'm going to copy all of these links into the chat so that you have them, because now it's important. Okay, there we go. Sorry, the formatting kind of got messed up. Do we have everything there? There we go. I think so. So one kind of art is poetry. And the concept behind what we're going to look at today is called an amulet. And this was created in February. This concept of this poem was created in February by an author. I'm not sure where they're based. Robin, somebody. I don't actually remember the name. I'm sorry to say, but basically, they're combining art and code. So they're saying that a poem is an amulet if its complete Unicode text is 64 bytes or less, so relatively short, and if the hexadecimal SHA-256 hash of the text includes 4 or more 8s in a row. And they set a minimum on the number of 8s. It has to be at least 4. So common would be 4, uncommon would be 5, et cetera, et cetera, et cetera. And they were saying, why don't we turn this into an NFT? And if you want to play around with this, you have the link there. There's a link partway down, which is this scratchpad might be useful. In fact, I'll link this directly as well, because it could be helpful, so you don't have to find it. Basically, you can type in a poem here, hello world, and it's going to tell you, is this poem an amulet or not, right? 11 bytes long. You can load some examples if you want. So if you can't write poems, write me. This one is an uncommon amulet. It has 5 8s in a row. Don't worry is a common amulet. It has 4 8s in a row. There's another one. There's another one. There's another one. As you can see, as you start to type things in here, it's fairly hard to get a complex anything beyond sort of 4 5 8s. In fact, if I just type in hello Jello or something like that, I'm not getting more than 1 or 2 8s in a row. So there's an element of luck, let's say, that's also contained in this. Now, what somebody did, a gentleman by the name of Nick Johnson, who's a early Ethereum developer, he basically turned this into a smart contract. And what you can do is you can go here. The link is there to the original source code. You can do the standard, git clone and then cd into the directory, yarn install. You can do that if you want. If you want to get into this kind of blockchain development, I recommend trying it with this or with another smart contract example, smart contract. But we're not going to do that here because There's a lot of dependencies to install. It's going to put about a gig of JavaScript gigabyte of JavaScript dependencies on your machine. So just warning there. And we have a much simpler version for you in a second. There can be a social aspect to it for this NFT. So they also deployed a Twitter bot that basically tweets out new amulets. So here's a new amulet, which consists of these emoji. Here's one where, what's this one called? This is a legendary amulet. So sanctimonious equals prattler plus deist. And if I come back here to my scratch pad and paste that in, I indeed get a legendary amulet. What is that? Like 8 8s in a row. So did this person randomly find this out, discover this, or did they write some program to generate it? We're not really sure, but it's kind of nifty. There's also a marketplace around them. So these, there is a smart contract deployed for these amulets that you can mint to on the public Ethereum blockchain, and you can list them here on OpenSea. I'm not sure that anybody has sold one yet, but it's kind of fun, if you will. It's a bit of fun. What we're going to do, rather than doing the old standard, GitHub clone, yarn install, et cetera, is we are going to use something called Remix, which is a web-based smart contract IDE, or integrated development platform. And I'm gonna walk you through using it, because I think it's important. I think it's useful to understand kind of how all of this works before we get into just running npm scripts. I also have prepared what's called a flattened version of the contract with some simplification. So if you click on that link, which is in our GitHub, and you come here, this is, we'll just use this source code, and it's a few hundred lines long. If you click on raw, it should take you to the raw file, and then you can just Control A and copy it, and then go into Remix. So this is Remix. This is an online IDE for developing blockchain applications. When you first come here, you can click Solidity. That'll set up the Solidity installation for you. You need a version 8 compiler. So 0.8.1 should be sufficient. And then you will come, then you can click on File Explorer. And if there's no workspace here, you can click plus. It should take you to basically what's an empty workspace. You can click into contracts and see some example contracts here, some example smart contracts. We're going to create a new file. So this icon, create new file. We're going to call it amulet.sol. And I'm going to paste in my code now, all 939 lines of it. And then I'm going to click on the Solidity icon again, Solidity compiler. And again, Solidity 0.8.1, compile amulet.sol. And if all goes well, and it could take a little bit of time, it should work. I get the checkbox there. All right, that was a lot, quite quickly. Any questions? If you do have questions or problems, feel free to drop them into the chat. I'm happy to help you and go over some of this again, or one of your fellow compatriots may be available to help you as well. So we've got this smart contract code here, and we've compiled it. Now, what we can do is we can deploy it to a blockchain. Yes, we are creating a new token. We are going to create this ERC 721 token. ERC 721. Is it listed here? Here we go. ERC 721. It is the amulets token. You can see it has a function here, for example, that returns its name, returns its symbol. And we are going to deploy this pre-made token onto the blockchain, and then we are going to make some modifications to it to see how we can play around with it. So I'm going to click on deploy and run transactions. Now, in this window, I'm going to notice a few things. I want to point out a few things. So again, we have File Explorer. We have the compiler, the in-browser compiler, which is compiling my source code into bytecode. And then I have my virtual machine where I can deploy and run transactions. So we've got three options at the top here for environment. We have JavaScript VM, which is basically saying do everything in the browser. That's what we want. If I wanted, though, I could actually connect it to a real blockchain. And if I chose injected Web3, for example, it's going to say like, hey, are you really sure you want to connect? And now I'm interacting with, the real Ethereum blockchain with this address on the main network. That is not what I want to do. I want to use a JavaScript VM. It also gives me a series of accounts, and it preloads them with 100 Ether. Ether's what? One Ether is about $2,400 right now. I would be rich. I'm not. It's fake money. I need it to, first of all, be able to pay gas. Everything costs gas, even within this fake JavaScript VM. So I need to pay transaction fees. Yeah, that's what these accounts are for. So it's generating these accounts with either a fake or a throwaway private key in the background, right? I have this account address, these account addresses with 100 Ether, so I can just leave it set on the first one. The next thing is the gas limit, and I was in this before, and I think the default gas limit is 3 million. I would set it to at least 8 million. You don't need to go crazy, but 8 million, 8 with 6 zeros should be a good amount. The next thing I have is the value, because we're about to send a transaction. Should I be, what value should I use? And I'm going to set that to 0 because I don't actually care about sending any Ether with this. In fact, you have to leave it at 0 for various reasons. Now, I also have contract dropdown, and the way that the smart contracts are put together is you can put them together as a series of essentially almost like objects, right? So each of these, so for example, I have the address library. Look, search here for contracts. So contract amulet, right? I have the amulet contract. I have the, what other contracts do I have here? These are abstract, but it will still compile them. So let's see, interface, I have the ERC 165 contract. If I look through this list, I have these contracts as well. I don't want the first one, which is address. I want the second one, which is amulet. That's what I want. And then before I go to deploy, well, I have my deploy button now. I've selected a contract, I have my deploy button. I have to pass it what are called constructor parameters. One is called pre-mine mints, and the other one is called pre-mine reveals. And I'm going to get to those in a second, but I see some questions. So let me come and take a look in the chat. Yes, fake gas. You can switch the HTTP to HTTPS in the browser bar. It might default to HTTP, but you can switch to HTTPS, and I would recommend that. Yep. Thanks for answering the questions, LD and others. Just a test network, not real money, not a real blockchain, just running in my browser. So what are these pre-mine mints? Now, I think as a software engineer, one of the ways that I learn is by reading other people's code and going through other people's code. So, rather than just telling you what this is, let's go on this journey together, right? And try and figure out what to fill in here. So pre-mine mints, let's do Control F for pre-mine mints. And this is in a function called the constructor, right? So the constructor is just like you would with in any other object-oriented programming language. Or this is not an object-oriented programming language. Solidity is not an object-oriented programming language, but you would have constructor that would essentially create the object or create things for you. And in this case, it creates the smart contract. I can pass in these values, and they are arrays as indicated by the double square brackets. So I'm going to pass in actually nothing for them. So I'm just going to pass in an empty array or an empty tuple. All right, selecting an account, gas limit to 8 million, no value, left that default. Second option here, amulet, pre-mine, pre-mints, just empty. Let's hit transact for deploy. If you didn't expand this, you would have just had it look like this. So deploy, and let's see what happens here. Can I clear this? I'm going to clear this. Deploy. And it worked. If you get a green checkbox, it worked. If you get anything else, it did not work. And you can try looking through what happened there. Now, for this transaction, what this means is that from my from address, which represents my address up here, I have basically said, create a new smart contract, and it has deployed it to this address. The smart contract gets its own address, and it has essentially deployed the bytecode. This is, if I was to copy and paste this into a text file, I'd see all that bytecode. Now, my amulet is deployed, and I can interact with it, right within the browser on my fake blockchain. So let's take a look at the name. I'm going to click this button. There's no parameters for this function, and I'm going to get back amulets, the string amulets. All right, so if I search through my source code, and again, whoops, search for name, function name, it's as I expected, amulets. If I click on symbol, which is right there below it, I'm going to get amulet. These are read functions. They don't cost me any gas to execute because I'm simply talking to my local blockchain node, which in this case is my browser, but my local blockchain node essentially doesn't have to pay any gas to return me information from that's on the blockchain. I only have to pay gas or transaction fee if I'm writing to the blockchain. So something else I want to call out here is these functions look very, very simple. They are. It's like programming in, Visual Basic, or, programming in the most simple form of JavaScript. But there's a lot wrapped up in this. So function name, and that's where it gets complex, is what I meant to say. That's the name of the function. Public means anybody can access it. View means that it only reads from the blockchain and doesn't write to the blockchain. Virtual, this is using a version of Solidity that I don't spend a lot of time with. I think virtual just refers to the fact that actually, I'm not entirely sure. I'll have to look that up, but I think it refers to the fact that it overwrites an earlier definition. And then it returns a string, which is simply held in memory, and it's going to return this constant string. That's it. It's that simple. So why is this so complicated? It's so complicated because we're not programming just for a fake blockchain running on a browser. We're programming for a blockchain that is public and is running across everybody's computers. And I'm going to show you an example of where that gets complicated in a couple of minutes. Chat. We're having a break at some point. We are not having a break. We are recording this. The breaks were for questions. So I know we're going quite quickly. If you do need to take a break, please, I should have said earlier, step away at any time, and you can always pick it back up on the recording if you miss something. So we're going to interact with the smart contract in a second, and we're going to try calling the mint function. Now this takes data as a tuple. And a tuple means basically an array. So how do we interact with this? How are we going to mint a token on here? Well, let's try and figure it out. So we're going to mint, and mint takes this mint data and does a few things, does a few checks. It checks to see if the owner is not the zero address. We don't want to basically make it create the token to an owner that nobody can ever control. We want to make sure that the existing token ID doesn't already exist. And then we're going to add it to our tokens. We're going to add basically that data into our list of tokens. We're going to say, hey, we have just minted a token. So we're going to try calling this. Now we need to figure out what mint data is. So let's see, mint data is here. It's an address and a token ID. What is a token ID? Token ID, coming back to the last link here, is simply the Keswick 256 hash, not the SHA 256, but the Keswick 256 hash of our NFT. And because I'm fairly unoriginal, I am going to crib from one of the other amulets that was already created. I had one here, didn't I? Didn't have a better one? Wild amulet appears. Let's pick one of these. Whoops, that's the Beeple thing. Let's pick one of these legendary ones. So sanctimonious equals Prattler plus Deist. I'm going to plug that into my Keswick hasher, and I'm going to use it to generate my token ID. This is my token ID here. Now, it's outputting it as 64 bytes, I believe, of I believe it's 64 bytes of hexadecimal. In order for it to work with Remix, you need to put a 0x in front of it, and you also need to wrap it in square brackets. So 0x square brackets, 0x, paste that number in there. And then that's actually the second parameter. The first parameter is the owner. I'm going to make myself the owner. So I'm going to come back up to the accounts. I'm going to copy from here. I have to surround it in quotes again and paste. Now we're ready to mint. And let's see what happens. So let me collapse this. This was my deployment transaction. That was my call to amulet.name and amulet.symbol. Here I am at the bottom of my console again. Got mint set up, square brackets, quotes, 0x in front of the address and the Keswick hash. I'm gonna click mint, and there we go. I have minted a token. So like, if this seems like it's going quite slowly and is kind of like finicky, this is the state of the art of blockchain development today. I mean, there's all sorts of other tools that you can use to make things faster, Hardhat or Truffle, you know, that plug into Yarn and NPM and things like that. But when it comes to debugging smart contracts and dealing with them this way, this is essentially the state of the art. Is using something like Remix, literally Remix, or something like Remix that is plugged into VS Code. It is not yet at the state of Java or Python or Go with all sorts of, or JavaScript with all sorts of fancy debugging tools and you know, being able to use nice names for things. And a big part of that is related to gas fees. We're trying to optimize for gas as much as possible here. One kind of nifty trick is clicking on debug, and I can basically roll forward, step forward. Where are we here? I think that's go to the end. I can step forward through the things that it's doing. I have to go here. That's probably going to take it to the end, right? Step forward, next line, step in. There we go. Step in. Everything looks good, and yeah, I can undertake this this debugging. Some questions, I think. Okay. We will possibly come back to those, and thank you for all those engaging in conversation on the chat while I'm being a prattler here, prattling on, because it's certainly helpful that we're helping one another. So I've minted the token, but it's not revealed. It's not revealed. I've simply put a hash of the token onto the blockchain. So there's a two-step process here. I can actually mint and reveal at the same time. I can also mint the token and then reveal it later. Why do we do this? This is where we start to get into the blockchain complexity. Why do I bother putting a hash of the token, which is that becomes the token ID, and not just the token itself? Because as soon as I send this transaction to the blockchain, it's sitting in what's called a mempool or memory pool or transaction pool. And if I come to Etherscan here and I go to where are we here? Blockchain, view pending transactions. I can see that I have, here's all my pending transactions, my 176,000 pending transactions. Now, realistically, a lot of these are basically dead in the water and not going to get confirmed. But all of these have been seen within the last few seconds. And the only ones that are going to get included into the next block are the ones that are paying the highest transaction fee and are paying highest transaction fee and are will fit into a block, right? But even then, I still have to wait. I may have to wait up to 12 or 15 seconds, even if I get included in the next block. During that point in time, excuse me, somebody else can look at my transaction, can observe my transaction in here, and go, huh, that's a really good amulet. In fact, it's legendary. I would love to own that. Why don't I just call that same smart contract with this amulet and a slightly higher gas fee, and I will get it in first. And then the next transaction is going to fail. The original creator of that. And in fact, if I try that again, so here's my successful mint, I'm going to call mint again with the exact same parameters, and it's going to fail because I'm trying to mint an existing token. And this, in a broad sense, is called front running. And the reason therefore, they have chosen, the contract author has chosen to put a hash in here instead of the actual poem itself, is so that anybody that's front running this has no idea if what they're getting is worthless, or if what they're getting is potentially a legendary or epic token. And this is where the complexity starts to come in, because you have to think about it. I am not just programming for my computer. I'm not just programming for the internet or a cloud service. I'm programming for a world computer where anybody can represent, where anybody can observe the data and the code in real time, while it's being executed, after it's being executed, and even before it's being executed. Questions? Okay. All right, how are we on time? We're right up time. I'm going to run for a few more minutes and then leave you with an exercise for later. So let's take this to its conclusion. So we're going to reveal now. How do we reveal an amulet? So function reveal. So we need this reveal data. And we're going to look up reveal data. What does that structure look like? A title, an amulet, and an offset URL. So again, with the quotes, title, amulet, offset URL. The offset URL is actually for its carbon offset, which I don't have, but we can put in a placeholder here, https example.com. The title is going to be my first poem. And what I'm going to paste in here is the actual amulet itself. So sanctimonious equals prattler plus deist. And I paste that in. I'm going to click reveal, and hopefully this works. And there we go. It's revealed. And if I look at this, I can see the results of the transaction. So my first poem, and it in fact was issued, which I'm very happy about, very proud of that. And I think if I come down here and look at URI, if I punch in the token URI, it's a token 0. And I do URI, I would get ID JSON. That's not helpful. Where are we here? Is revealed. Is token ID 0 revealed? Is revealed. Did I output that down here? Oh, because the token ID is the giant Keswick hash, of course. Not remembering my own advice here. And this might have been what I did earlier. So let me pick this one. Token ID revealed, 0x at the beginning, is revealed. Yes, it's been revealed. So the exercise is to, if you want, to take a look at this code and read it, see if you can understand it, and then see if you can make it accept an amulet which is more common. So that doesn't just have, let's say, at least 4 8s, but maybe has only 3 8s or 2 8s and 1 8. And I think for a beginner level introduction to blockchain, that's a pretty good place to start. If you can modify the smart contract, figure out how to compile it, redeploy it, and then find an amulet. You can use any amulet because it would have fewer 8s than that. But you could, if you can then also potentially find an amulet that has 1 8, or maybe find an amulet that has 2 7s or something like that, that it would accept. That is the exercise I will leave you with. Now I'm going to come back because I do want to touch a little bit on reducing climate impact. So first of all, actually, let me come back to that in a second. Improving usability. There's just so much more work to do in this space. And if you're interested in, if you're looking at AI, machine learning, drones, web services, games, blockchain is a great field with, I think, years, if not decades, of interesting things to do ahead of it. And long-term prospects beyond the career, why can't we represent real estate, or why couldn't we represent a car or a building? Well, that is real estate, or anything with the serial number through an NFT. I think that's really the long-term prospect around reducing climate impact. I'll share this link, which talks about the climate impact of NFTs. And where are we here? Whoops, it's not supposed to be everyone in meeting. we go. I send all those links. Yeah, everyone. So this one, the unreasonable ecological impact or ecological cost of crypto art. I think this person has a pretty good point when it comes to the public blockchain, the public Ethereum blockchain. And since the Ethereum blockchain went live in 2015, from day one, we've known about this problem. The idea basically is to move to what's called a proof of stake with ETH 2.0, and that is in progress. The other option in the short term is to use a blockchain that uses something other than proof of work, which basically involves using a lot of electricity to secure the blockchain. So blockchain uses energy, substantial amounts of energy, public blockchain, in order to provide a level of security around the transactions. We don't need that if we come up with a better way of doing that on public blockchains, or you use a blockchain that uses a kind of a different mechanism for securing it. And that's really where the future is. So that's also why, I think it's kind of cool with the Amulet smart contract. It includes this offset URL, right? Where the intent is that you basically include a carbon offset as well to offset the electricity. You actually go out and buy a carbon offset and then prove it through this URL. Of course, there's no way for the smart contract to validate that, but that is what it's all about. Again, I wanted to, conscious of time, we're 6 minutes past. I'm going to pause there, end the presentation there. Thank you, everyone. If you want to know more about what I do in my day job and learn about Multibas, our blockchain middleware, which makes it fast, easy, cost-effective to build multiple blockchains, please do ping me, jeff@curvegrid.com. Go check out our website. If you do have questions about, it doesn't have to be about Curvegrid, of course, about this or blockchain in general, happy to engage. So thank you, everyone. If you do have any other questions, feel free to drop them in the chat. And I'll try to go back through some of the ones maybe I didn't get to. It reminds me of buying and sitting on URLs, domain squatting. Absolutely, exactly. And a big part of how a blockchain strategy and smart contract strategy today is kind of all around that. Where are we here? There was one. How does fund transfer in seconds relate to the among of unpredictable time to create a smart contract for NFT artwork use case? Maybe that is the amount of unpredictable time to create a smart contract. So the time is unpredictable in the sense that the blockchain is only immutable once a certain number of blocks have been mined or secured or created, because the way that the blockchain is like an eventually consistent database like MongoDB. If you've ever used MongoDB before, you will know, or you should know, that if you have more than one MongoDB connected to one another, in fact, it's not just MongoDB, it's any DB, but let's say MongoDB, that just because you've written to the database, doesn't necessarily mean that it has made it into the database in the order that you think it's made it in. And it's the same thing with blockchain. It is possible for blocks near the top of the blockchain to basically get unwound and all of their transactions discarded and then applied again. And this is like these are called chain reorganizations. They're very commonplace. They're necessary part of blockchains, public blockchains, but it's a lot of complexity to deal with. And that's a big part of that. So, but anyway, for an NFT, if you wait, usually, if your transaction's accepted by the node, it's probably going to go in there. If not in the next block, eventually, within a few blocks. And if it's in a block, it's probably going to be in there or be back in there. Of course, as I said, there's all sorts of exceptions to that. There's front running, et cetera, et cetera. If you're buying a coffee or sending somebody, a small amount, like, hey, I'll pay you back for lunch, or here's my NFT of my artwork that I draw for fun, and it doesn't really have any value, immediately you will know if that transaction is likely to be accepted or not. If you're buying a Beeple for $69 million, you probably want to wait about a minute to make sure that's confirmed. But you know what? This speed is no different than, let's say, a Visa transaction, right? You go to the store, you pay with your Visa card, you tap your Visa card, or you swipe your Visa card, and it takes a few seconds, right? I mean, it's not instantaneous. It takes a few seconds for the transaction to be confirmed, but the merchant doesn't get paid their 69 yen or 690 yen or $69 million for 30 days or let's say 14 to 30 days. That is the matching, the settlement, and the clearing time. That's the full time that it takes for a Visa transaction to complete, is 14 to 30 days. Whereas on the blockchain, we're talking hundreds of milliseconds to, a minute or a few minutes. I think I covered most of these. Yep. Great links. Thanks for sharing, everyone. Why do people pay those ridiculous prices? It's a market, right? So let me show you another cool bus. Where are we here? Ethereum Transaction Bus. Here we go. TX Street, Transaction Street. I will paste this in the chat as well. So this is here's the chat here. This is kind of cool. This is kind of cool. It's sort of a visual representation of how the blocks are getting generated on Ethereum. Right, so all these little cartoon characters, they're coming from the different decentralized applications. There's OpenSea, there's CryptoKitties, that's Yearn, I think, Finance. That's US dollar Tether. And all these transactions are submitted to the blockchain, and they line up for the bus, and they line up in order of how much transaction fee they're willing to pay. And the miners are basically doing their thing to secure the blockchain, and they say, great, they're collecting all these transactions, filling their bus with transactions. And so, this one is 111 gig away. If you're paying at least that, or now 118 gig away, you will get on that bus, and when it's ready to go, it will leave. If you didn't pay at least that amount, your transaction's getting off and getting on the next bus. Yeah, this is pretty cute. I love this too. Is there any existing application for digital health? Yeah, absolutely. There absolutely is a use case for digital health. That goes back to identity, potentially, like your medical records. And it's more than just proving the medical records are yours. You could, for example, your medical records could be represented by an NFT, non-fungible token, right? That you could say these doctors and these hospitals or these research institutes have the right to view my medical records or the right to use them for research. And maybe a research institute might pay you for getting a look at a portion of your DNA or a portion of your medical records. You have some condition that they're very interested in, that they're looking to develop a new drug or treatment around. Another example is that's a great example, Kane. Vaccine passports. Tons of possibilities. Blockchain is definitely not the answer for everything. Sometimes, many times, you just need a database. But there are a lot of existing applications where I think we're going to see this technology replace it in the back end in some way. The back end of banks, the back end of marketplaces, the back end of identity management. And sometimes it's going to be a public blockchain. Sometimes it's going to be a private blockchain where the whole thing is basically just a blockchain, but being run amongst a group of participants. So I think there's no more major questions. Hopefully I covered most or all of them. I think I'm going to stop there, and just want to say thank you, everyone. Really appreciated the chance to speak with all of you, answer your questions. Please don't hesitate to reach out, and have a great evening, have a great day. I'll pass it back to Sasha now.